Hello, this video is for my friend Alec, who is a very smart microbiologist, but who doesn't like chemistry. He was complaining about a job interview in which he'll be tested on molarity. I have full confidence in him, but because I need to practice teaching before I start as a TA this fall, here's a short review of molarity basics for working in a lab. Okay, first a quick vocab lesson. Moles are a counting unit for molecules. Specifically, there are this many molecules in a mole. Molarity is the number of moles of solute per liter of solution. There are also some other terms for concentration of a solution like normality and molality, but these are not the same thing and also are rarely used in labs, so we're going to forget they exist. Alright, enough vocab, let's get back to science. There's only one equation which you really need to know, and that is C1 V1 equals C2 V2, which means the concentration times the volume of solution 1 equals the concentration times the volume of solution 2. And then the rest is all dimensional analysis, which just means making sure all the units match up. A basic calculation, for example, you have 1 liter of stock hydrochloric acid, that's 1 molar. You add 10 mils of that into 1.99 liters of water. What's the new concentration? We only have one equation, right? So let's write that down. That's C1 V1 equals C2 V2. And what we know, C1, the concentration of our stock acid is 1 molar, and V1, how much of it we use, is 10 mils. 10 mils divided by 1,000 is 0.01 liters. And then V2, the total amount of solution we have at the end, that's how much water we have plus how much acid we're adding to that for a total of 2 liters. What we're trying to find is C2, the new concentration of our 2-liter solution of water and stock acid. So we plug those into the equation, and we get one molar times 0.01 liters equals C2 times 2 liters. And so we got to make sure that our units cancel out correctly. That's why we're using the 0.01 liters of stock acid versus 10 mils. And then, so we can cross out liters there, and we have 0.01 C2. So 0.01 equals 2 times C2, and dividing both sides by C2 or by 2 gives a C2 of 0.005 molar. Sometimes the units aren't quite so easy, and that's where the dimensional analysis comes in. Say we want to add antibiotic into a 1 liter fermenter. We want to add kanamycin into the media at a concentration of 0.1 millimolar. The canned stock has a concentration that is 50 mg per mil, which is the concentration in mass per volume rather than in moles per volume. So now for the dimensional analysis. To calculate the canned concentration, we simply have to cross out the units. That is 50 mg per mil of can times 1,000 milliliters in a liter. That accounts for the volume unit there. Then Google tells us the molecular weight of kanamycin is 484.5 grams per mole, and we're going to multiply by the inverse of that because we want moles on top in our final unit. So 4.5 G. And then we see that our mass units aren't the same there, so we need to multiply by 1 gram is 1,000 milligrams. And so if we see there, we have mils cross out there, milligrams cross out there, grams cross out there, and we're left with moles per liter there. Okay, and so you multiply all that out. You can plug that into your calculator, or you can just trust what I plugged into mine to get 0.103 moles per liter, which, remember, is the unit for molarity. So that's 0.013, whoa, that's not what I meant, 0.103 molar. And that's our can stock concentration. So C1 V1 equals C2 V2 again. And remember, plugging those in gives us 0.103 molar times V1 equals 0.1 millimolar times 1 liter. And the concentration units still don't cancel out, so we can go in either direction on these, because it doesn't matter what the units are, so long as they are the same ones on both sides of the equation, right? So we multiply the can concentration by 1,000 to get 103 millimolar, which we can then cancel out on both sides of the equation here. So millimolar, millimolar, and we get 103 V1 equals 0.1 liter. And so we plug into our equation, solve for V1, and we get 0.00097 liters, which is 0.97 mils, or 970 microliters. So that's such a small volume compared to the 1 liter of broth already in the fermenter. That's why we're allowed to discount the extra volume here that we added for when we're getting our V2. So thank you very much for watching, and if you want a video on another topic, let me know and I'll tell you if it's something I know enough about. Good luck with the job search, Alec.